Hello coders, welcome to our channel Level Up with Coding. Today I will discuss about the Leetcode daily challenge question count subarray with fixed bounds. The question says you are given an integer array nums and two integers minK and maxK. A fixed bound subarray of nums is a subarray that satisfies the following conditions. One is the maximum value in this subarray is equal to maxK and the minimum value in this array is equal to minK. So the question saying you are given an integer array nums and two integers, that is minK and maxK. You have to return the number of fixed bound subarrays of the array. Okay, and a subarray is a contiguous part of an array. So basically in the example 1 you can check you are given a nums that is 135275 and minK is basically 1 and maxK is basically 5. The output is basically 2. Why? In this explanation they are saying that the fixed bound subarrays are 135 and 1352. So in this array the good subarrays are 2, that's are 135 and 1352. Okay, in the second example they are given 1111 in the array and the minK is 1 and the maxK is 1. So basically the output is obviously 10 na, because 1 and then 1 1 and then 1 1 1 and then 1 1 1 1. So that's we can easily find the 10 types of subarrays. Okay, and in this constraint you can check is 2 is less than equals to nums dot length is less than equals to 10 to the power 5. So it's basically saying ki it's 10 to the power 5. So it's obviously sure ki brute force is not possible in there. So we can do either O of log n or O of then condition code. Okay, so now we will discuss in pen and paper. So now currently doing the question count subarray with fixed bounds. Okay, the problem asks for counting the numbers of subarrays in which the minimum elements is at least minK and at the most maxK. Okay, so now we are doing with an example. Okay, the example like 1 basically nums equals to 1 3 5 2 7 5. Okay, and min is what? minK is what? 1 and maxK is what? 5. That's they are given us. And fixed we have to return a fixed bound subarray. Okay, you can check 1 3 5 2 7 5. This is the array and minK is 1 and maxK is 5. So how it's do? So first of all we can check with 1 and 3. Okay, so you know na what is subarray, you know. Okay, so now we just do the question. Okay, so first of all we can check 1 and 3. So you can check it that their minK is what? Their mean element 1 and 3, their mean element is what? 1 and maxK is what? maxK is 3. It might be possible but it is not possible because their max is 3 but we need max is 5. So we can check with another one. So we can check with 135. So 135 their mean is what? 1 and the max is what? 5. It is possible. So count is basically 1 because 135 this is a good subarray and the mean is 1 and the max is 5. This is good. Then we can check with 1352 their mean is what? 1 and the max is what? 5. So this is also. So count equals to what? Count is 1 plus 1, that is 2. Okay, now we will check with 1 3 5 2 and 7. Okay, so minK is what? 1 and maxK is what? maxK is what? 7. Now you can check that mean is 1 but max is 7. This is greater than max, greater than the max. Okay, greater than the max. So we cannot do this. So this is written 0. Okay, also you can check with this. So 1 3 5 2 7 5. So their minK is 1 and max is also 7. So this is not possible. Now this subarray is done. Now you can check with 3. So 3 and 5. So 3 and 5. Now this is not possible because mean is 3 and max is 5. You know na their mean is 1 but it's written there the mean is 3. So this is not possible. So we cannot do in these subarrays. Okay, also we cannot do in these subarrays because their mean is check there. So 5 and 2, so mean is what 2 and max is what 5, so it's not possible now because we know ki mean is 1. Okay so this is not possible. Then 2 to 5, that is not possible. So you when you do all types of areas, all the areas, then you know it that the count is basically 2 there. Okay so now you can check with another one example. Okay, so example 2, basically 1 3 5 2 7 5 2 1 8 and 5. Okay, so we can check with 1 and 3, but it might be but not, so we can check with 1 3 5. Okay, so minimum is what? Minimum is 1 and maximum is what? Maximum is 5, so it's possible. Okay, so count is basically what? 1 and 1 3 5 2, that this is also possible. So 1 3 5 7, this is not possible. So 1 3 5 1, this is not possible because in all these subarrays there is a 7 that is greater than 5. So in these types of subarrays they are not possible. Okay, so we do with 3 we can do, but the mean one is 1, so it is not possible in there. When you do all types, all the cases, you can check with 5 to 1. Okay, 5 to 1, so 5 to 1 because their mean is what 1 and max is what ki 5, so also possible. And there are no any other, so there the output is 3, and in the first example was there the output is 2 because count is 2. So this is the problem. And now we have to decide how we solve it. Okay, how we solve it? So now in the upper description, so now in the upper what I described there, you know ki one condition there, one condition. What the condition? Condition is nums of I, okay, is greater than mean k, or nums of I is less than mean of k, or greater than max of k. So this is must the condition. Either this condition is not matching, then wrong. Okay, so first of all this one. So how we solve the question? So approach, we can initialize mean boundary, that is -1, max boundary, that is -1, and the bad boundary, that is -1. Now I am describing about the what is mean, what is max boundary, and what is bad boundary. Just like 1 3 5, so mean boundary is this, and the max boundary is this, and 7, so this is the bad boundary because this is never like the condition. Okay, so this is the bad boundary. So I just initialize all of them in -1 form. Okay, now we initialize a count that is 0. Okay, now we have to decide that our bad boundary is positioning in 3 areas. Just look like that. First area is in there we have the array elements, and there have mean boundary, and there have the max boundary. Okay, so there have to the bad boundary. Okay, next area is basically we have the mean boundary, in there we have the max boundary, and in there we have the bad boundary. And in the third condition is this, in there we have the mean boundary, in there we have the bad boundary, and in there we have the max boundary. So these 3 types of things are there, and the bad boundary and in there the bad boundary are there. Okay, so you can check that in there we can easily do it. Okay, because the bad boundary is in the left side subarray. Okay, and in there we can easily because the right side. Okay, but in there the bad boundary is the middle. So this is invalid. Okay, because you can check that we have many elements in this array. So there we have the minK, there we have the max element, and now there will be bad boundary. Okay, so just look 1, 5 and 7. Is this possible? No, no. How is possible? Mean is 1 but max is 7. How is possible, right? So this is one of the most condition. Okay, let's we initialize these things. So now how we to do? So you know now I discuss about one condition, but just you initialize these things and just you have to iterate through the array. Okay, you have to iterate through the array and then check if the current element is within range what minK and maxK. Okay, if yes, what you do, update the indices. Okay, indices of the last occurrence of minK and maxK if necessary. Okay, and second key, count the number of valid subarray between left bound and the smaller index among the left bound and the smaller index among the last occurrence what minK and maxK. Okay, if not, so what we do, easily just update the left bound to current index and reset the indices of the last occurrence of minK and maxK, and at the end just return what? Return the count. Okay, count. So now we write the algo part. Okay, so basically we initialize a mean bound, that is -1, max bound, that is also -1, and bad bound, that is also -1, and we initialize a count, that is 0. So we do a loop that I describe in the approach part. So loop what we will do, we do I equals to 0 and I nums of size. Okay, and I plus plus. Okay, so what it's do is do look 1 3 5 2 7 5, we starting from there and continue till end. Okay, in the loop what we will do, we will check the main condition that nums of I is less than minimum of k or nums of I is greater than maximum of k. Either it's possible, then bad boundary is updated. Okay, I described about this in approach. Then if nums of I is equals to minK, then mean boundary is updated, and if the nums of I is equals to maxK, then the max boundary is updated. Okay, at the end what we will do, count plus equals to max of 0 comma mean boundary and the max boundary minus bad boundary. So now we will discuss about what this, so now we will discuss about what it's do. Okay, so 1 3 5 2 7 5 2 1 8 5. Okay, so what we initialize, mean boundary -1, max boundary -1, bad boundary -1. We just starting from 1 and going to 3 in this loop. We just starting from 1 and going to 3. Okay, so there basically our min boundary is -1, so we just initially we just doing right now 1, and the max boundary still might be but it's not, so we doing 1 to 5, so max boundary is basically 5 hour. Okay, and there is any bad boundary? No, there is no bad boundary. Okay, so now what was there, that just check mean boundary, mad boundary, this is not, so it's done. Now the count is what? The count is basically 0 plus max of, okay, max of 0 comma mean of mean bound and max bound. So bound is basically what in there? 0 1 2 3 4 5 6 7 8 9. Okay, so mean bound is what? Mean bound is 0, 0, and the max bound is what? Max bound is basically 2. So what in mean bound is written 0 and minus what? -1. So 0 minus -1 is what will it's written? 0 minus -1 is written 0 minus -1 is written 1. So now you can check that max of 0 comma 1, because just look 0 plus max of 0 comma 1, what will written? 1. So count is now will written 1. So now this type we can just answer the count. We can just answer the count. Basically is there the count now is 1, and also we can check with 1 3 5 2. Just look 1 3 5 2. Okay, just look 1 3 5 2. Now count is basically 1 because 1 3 5, so their count is 1, so count is now basically 1. So plus max of 0 comma 0 comma, so you can check the here 0 1 2 3. Okay, so max is basically 0 comma 0. Okay, and is what? Minus 1, so is also written 1. Okay, so count is basically 1 plus 1 and count is 2 in 1 3 5 2 there. Now you check with 1 3 5 2 7 1 3 5 2 7. Okay, just now you can check 1 3 5 2 7. Okay, 0 1 2 3 4 in there. So count is basically what? 1 plus max of what? 0 comma in there mean is what? 0 and the max is what? 4. Okay, so we just start with 0, and now what is different in there? 4 is 7. Okay, and the bad boundary you can check nums of I is less than minK, or nums of I is greater than minK, then max boundary is updated, and the max boundary 7 is updated there. Okay, so mean is 0, and now what is done? Minus 4 is also done there. Okay, done -4. Okay, so max of 0 comma -4, what written? 0. So count is basically there 0. So that's how so count is basically there 0. So that's how we do this question approach. Okay, because you just check when we use the boundary 0 1 2 3 4, when the element size is greater than the mean, greater than the max. Okay, greater than the max, when its size is greater than the max, then we initialize the boundary bad boundary with the element. Okay, and we are just count it by this easy mathematic topic. Okay, just max of 0 comma mean of mean b and max b. So we easily check with the mean b, and then we minus with the bad b, then we easily count the count. Okay, so that's how we do it. Okay, so now we code it. So we are coming in the code editor, and now you can check it that the constant is basically 10 to the power 5. So we are code it in O of n time complexity. Okay, so now we can code it. So we are initialize n, that is nums of size. Okay, now we are initialize mean b, that is equals to -1, and we are also initialize max b, that is equals to -1, and we are also initialize bad b. Okay, that is equals to -1, and we are initialize long count, that is equals to 0. Now we are doing a for loop. Okay, in the loop we are starting from 0 to the nums of size, and in this loop we are just check if nums of I is within the range of minK and maxK. Okay, so for this we are checking with if condition. Okay, so if nums of I is greater than equals to minK and then nums of I is less than equals to maxK, so that we are doing if nums of I is equals to minK, update minimum bound to current index I. Okay, and now we are doing min bound is equals to nums of I equals to minK. Just check in the if else condition. Okay, if that is, then update the minimum bound, and if nums of I is equal to maxK, update the max bound to current index I. Okay, so doing in the if else condition in the max bound, just check it in the if else condition and update the max bound in I. Okay, yeah, oh shit. Okay, yeah, so now update the count by the number of valid subarray between min bound and the max bound, and smaller of min bound and max bound. Okay, and smaller of min bound and max bound. Okay, so now count is what? Count is plus equals to max of 0 comma min of min bound comma max bound and minus bad bound. Okay, so that's why the count is updated. Yeah, man bound, max bound and minus bad bound. Okay, or else we are just updating if nums of I is not within the range of minK and maxK, update the left bound to I. Okay, so yeah, and min bound is equals to -1 and the max bound is equals to -1. So at the end we just return the final count of valid subarrays. Okay, so now it is just easily submitted, and the time complexity, the algorithm iterates through the array once, resulting in the time complexity of O of n, and the space complexity is O of 1 since we are using only constant. So thank you. Please do like, comment and subscribe.